Tenakwe, Brother Guy. Welcome. So, Brother Guy Consolmagno, many people will be surprised to know, is the Vatican astronomer or the director of the Vatican Observatory. So, he was born in Detroit, Michigan. He obtained his Bachelor of Science in Earth and Planetary Sciences from MIT and his PhD in Planetary Science from the University of Arizona. He held postdoc positions at Harvard and MIT. And then he served in the Peace Corps in Kenya, teaching physics and astronomy, before entering the Jesuit order in 1989. Then came study in theology, philosophy, and physics until eventually he took up this assignment at the Vatican Observatory in 1993. And he's had many other visiting professorships and assignments. He has co-authored 2 astronomy books, Turn Left at Orion and Worlds Apart. He is the author or co-author of 4 books exploring faith and science issues, including God's Mechanics, Would You Baptize an Extraterrestrial? And he's also co-edited The Heavens Proclaim. And he has written a monthly column on astronomy for the British Catholic periodical, The Tablet. And we also know that he loves science fiction.
The title is a little odd, I suspect, because there was about 10 years ago, it grew out of a case where somebody wanted one talk from me and I wanted to give a different one, so I decided to glue the 2 together. In the process, I actually discovered something, which is what happens. They say people with floppy desks are the most creative because they'll have 2 different pieces of paper, totally unrelated, sitting next to each other, and they'll get some bright idea out of that. The bright idea of this is to remember that the way we understand any little bit of science in the scientific way we look at the universe is fundamentally dependent on the assumptions we're making without even realizing we're making the assumptions. And that's called a cosmology. And every little baby who's trying to figure out where their toes are is creating their own cosmology. Cosmologies change over time. There's a famous image, you've probably seen something like this before, the medieval view of the universe with a flat earth and a dome and stars in the earth. And if you only they could peer beyond, they could see the mechanism. Of course, if you know anything about medieval history, you know that's not a medieval view of the universe. That is an illustration of the 19th century cosmology that wanted to believe that the people in the Middle Ages were stupid. That's not at all what people in the Middle Ages saw. And the goal of 19th century cosmology was to come to grips with the changes going on in the world at that time. Just give you an example. What year is this now, 2025? If you were to go back 100 years and walk out the streets of Auckland in 1925, it'd be a lot smaller town, but it wouldn't be so fundamentally unfamiliar that you couldn't function. You'd know how to find a tram. You'd know what automobiles were and to take a look for them as you're crossing the street. You'd know where to get your news. You'd know how to make a telephone call, or at least the telephone calls existed. You'd know where to go to buy a loaf of bread. From 1925, if you went back to 1825, would you know how to buy a loaf of bread in 1825? Would you know how to get across town? Oh, you take a horse. Yeah. When was the last time you rode a horse? Do you know how to do that? The world of technology changed so radically from 1825 to 1925 that during that change, people came up with all sorts of crazy and bizarre ideas of, oh, I guess we're really much smarter than those people in the past. But in fact, that wasn't the way that people used to think. Science itself has been around for a long time. Before you could do and get your doctorate in philosophy or your doctorate in theology at the medieval universities, you had to take the trivial courses, grammar, rhetoric, and dialectic, and then the quadrivium, arithmetic, geometry, music, and astronomy. Now, that's the medieval university. Modern universities, of course, you can get doctorates in many things. I have a doctorate in planetary science. Actually, I have a PhD in planetary science. And the PH stands for philosophy. And when I went up to get my degree, they made me wear these long black robes and these weird hats. And maybe it's not so different from the Middle Ages. The point was that studying the universe is something we've been doing for a long time, and we are doing it because of our religion. The cosmology that we, inheritors of one way or another of Western thought, start with is the assumption that the universe is real. There are versions of Zen that say everything's an illusion, that I'm just a butterfly dreaming that I'm a philosopher. I cannot prove that that's not true. I have to take that on faith that the universe is real. If I'm going to be looking for the laws of the universe, I have to believe that there are laws there to be found. Hey, if I was an ancient Roman and the lightning bolt hits, I know where that lightning bolt came from. The god of lightning threw it. It's a perfect model that explains all the data. There are gods that made it happen. I cannot use science to disprove there are gods that made it happen because, it's a one-to-one. There's an event. I invented another god to make that happen. Sounds a little bit like quantum physics, but I won't go there. If I'm going to do science, I have to come from a cosmology and assumption that says, no, there aren't gods. And if there aren't, then where did that lightning bolt come from? The other thing, and sometimes this is the hardest, especially if you're trying to get money out of the government, is to believe that doing pure science is actually worth it just because it's cool to know pure science. I remember when I was a kid and NASA was selling the space program that it was going to give us Teflon, which it didn't. That's not why we went to the moon, to get Teflon. We went to the moon because it was hard. We went to the moon just to see if we could do it, just to live in the universe. Why would we want to do that? Especially if you believe in a religion that says the physical universe is evil. We should be spiritual people. And if you're worried about if you're tempted by chocolate, chocolate is the lure of the devil to give you acne and make you fat. But no, we believe in a cosmology that says God made the universe is good, and we physical people are the envy of angels. Quoting from my favorite New Zealand rock band, the Muttonbirds, who had an album of that name. And that we get to taste chocolate, which angels don't get to do. And chocolate is a foretaste of the goodness of God. It, in that sense, is a sacramental. Not a sacrament, a sacramental. Those are the assumptions. That's the cosmology underpinning everything we do. But in times before the technology revolution of the 19th century, there were three different ways of thinking of things that shifted in that 19th century. In the past, people thought that there was a golden age in the past and that we're in this inevitable decline. And, as in the world of rock music, I certainly think the music when I was a kid was so much better than that music today. And listening to your grandparents talk about the good old days, you can easily believe. Another difference was that before Galileo came along, if you wanted to study the universe, you could do it with your eyes and your ears and your five senses. Galileo says, no, you need a really, really special kind of instrument. And here I am, I'll sell you one. And the third change was the sense of what is it I'm actually attempting to accomplish? What counts as winning? Let me go over a few of these. I live in Rome half the year. I'm surrounded by the ruins of ancient Rome. And you look at them and you go, oh, yeah, it's a pretty interesting, if I were trying to play football in that stadium, the Colosseum, but if it's 1400 and you're surrounded by the ruins of Rome and you haven't built anything for 1,000 years, you're going to be convinced that those people were giants and there's no way we could ever be as good as them. The old idea was that knowledge was gradually fading over the centuries. Things are getting worse. Old people in every generation, things used to be better in the past. Look at the Garden of Eden. Look at the story of Atlantis. Even the Renaissance was using knowledge of old books because the people in the past, we can make a silver age that can kind of be like what the golden age was. But the people in the past could do marvelous things that we can't. The 19th century came up with what they call Whiggism. They're a bunch of ignorant savages. Civilization is getting slowly better day by day, step by step. I'm so much smarter than my parents were. And science eventually will make us all perfect. So in the past, you would look at the images and you go, oh my gosh, they were able to do amazing things. Now, with the Whiggish view, if they did anything, it must have been ancient astronauts, aliens from outer space who did that. Both points of view, I would argue, are ridiculous, but both points of view have enough going that you can kind of see what they're talking about. Along with that change was a change in how you expected the universe to behave. Let's say you go out and you pick up your morning paper. Does anybody get a morning paper anymore? Pretend you get a morning paper. And you notice a cat out front every day. Eventually, you put some milk out for the cat. And one day the cat doesn't show up. Well, cats are like that. The universe follows patterns, but not unbreakable laws. There's no way that I can prove something just because it didn't work, because, hey, it didn't work today. Things happen. The modern view is that nature is rigid, that success means I can repeat what I got the last time, and even quantum physics, which says the universe is unpredictable, it's predictably unpredictable. And if I, propose something and I do an experiment and the experiment fails, then aha, my theory is out the window. That's what at least we're taught in grade school. Famous story about Einstein came up with this theory called general relativity. In the 1920s, somebody came to him while he was still in Germany and said a bunch of experimenters had come up with an experiment in Cambridge that disproved a central point of your theory, Mr. Einstein. What do you have to say about that? And Einstein said, well, it's obvious. They made a mistake. How can you say that? And Einstein says in German, so it's much more profound sounding, he says, I know the universe. God is subtle. He's not malicious. My theory is so beautiful, it's got to be true. And sometimes, in that case, he was right. They had made a mistake. This is not the way science is actually done, but this is the way we tell ourselves that science is done. And that's part of the message I want to get across. The modern scientific world wants to say that everything occurs because of another domino knocking over the previous domino and finding the answer. Winning is being able to trace out the chain of dominoes. But that wasn't what was considered success in the past. Nor is it so much what we think of maybe success into the postmodern world. Certainly, we are using tools now that we could not use before. This in front of you is a 10-meter microwave telescope. It was one of the many telescopes used to make that wonderful image of the black hole. The little telescope with the dome behind it, that's the Vatican's telescope. That's the one that I've been raising money to pay for every year and that I've used in the past. And neither of these are telescopes that Galileo could even have imagined. So let's talk about Galileo. Because Galileo was in many ways the first modern scientist. And I don't just mean that he had brand new ideas or that he had used mathematics when other people didn't use it, but also he was a media star. Now, how many people recognize the guy in the middle, Carl Sagan? How many of you recognize Brian Cox? That's him actually visiting us at that. Science is done because we're curious, but science is also done because we want the pat in the head from people to say, oh, what a clever fellow you are. And I know Carl Sagan pretty well. I knew him. I met Brian Cox. There's a little bit of that going around in all of us. And certainly that was the case with Galileo. A lot of what I'm talking about, this is a book I highly recommend. There are hundreds of books about Galileo. The last time I looked at in Amazon.com, there were maybe 400 different books about Galileo, all of them telling you a different story, because Galileo is a fascinating character with a lot of things about his life we still don't understand. Galileo lived about 400 years ago. In 2009, we celebrated the 400th anniversary of the telescope, the year of astronomy. So let's pull Galileo 400 years into the future. It's 2025. He was born in 1964. Anybody in this room born in 1964? You're Galileo's age right now. Put everything in terms of who you are and what your age is. The Copernican system that he's going to get into trouble in the future for was devised during World War II. It's been around for a long time. It's not some radical new idea. Incidentally, was the Copernican theory a horrible, horrible bit of heresy that the church was going to stomp on? What happens soon after Copernicus's book comes out? The Catholic Church comes up with the Council of Trent. 18 years where they're finding heresies all over the place, and they never worry about Copernicus. It's not considered a heresy. It's not until 2033 that Galileo's going to get into trouble. How old will you be in 2033? Do the arithmetic. You don't want to go there. Not quite 70, but pretty close. Galileo's an old man, and he's been selling books for 22 years and living the high life on the talk show circuit before he gets in trouble. And, 5 years after that, he writes his best book on physics, which is not to say he wasn't thrown in jail or executed. No. Galileo was involved in the three fundamental shifts. The Golden Age mentality, he broke that down because he was able to demonstrate I'm seeing things that are not in any ancient books. I'm showing you things that the brightest people of the age past never knew. The role of instruments, he's the guy who invented it. But he also shows that if you don't know how to use the instrument, you're not going to be knowing what you're looking at. You're not going to be able to see it. And the last, that standard of proof, Galileo is still back in the past. He still doesn't have a modern sense of what constitutes winning. New knowledge. Just looking at the moon. How many people here have ever seen the moon through a pair of binoculars? I hope most of you. If not, find somebody with some binoculars some night. It's remarkable. And once you've seen it, you'll never forget it. Galileo was not the first guy to build a telescope. That was done up in the Netherlands. Galileo was not the first person to look at the moon through a telescope. Galileo was not the first person to look at the moon and draw a picture of what they saw. A fellow named Thomas Harriot did that. So that sketch is Harriot's picture of the moon long before Galileo's picture of the moon. What do you notice is different? Besides the fact it's in color. Galileo lived in post-Renaissance Italy as a young man, hung out with clubs that debated who was the best author in literature, who wrote the best science fiction. He was a big fan of Orlando Furioso, which is kind of the Lord of the Rings of his era. And he took classes in art, which included classes in perspective. His paintings of the moon look like balls, and he knows that he's looking at a sphere. Thomas Harriot, if he knew it or not, he certainly didn't know how to communicate it. Galileo knows that he's looking down on mountains from above, a viewpoint that no one had ever had, but he nonetheless was able to imagine what he was looking at. He produced knowledge that was not in any ancient books. The role of instruments. This is Galileo's telescope. You can go and see it at the Galileo Museum in Florence. Fabulous. If you ever get to Florence, you got to go to the museum. I highly recommend it. Something that I'll point out, the front of the telescope, that's where the main lens is, and he's blocked off most of the lens. Why is he doing that? Galileo did not understand how lenses work. Most people didn't. He just knew that if you do this and you grind this and you put two together, if somebody told him to do that, you'd be able to see things, bigger than they've seen before. And what he did not know was that the bigger the lens, the higher the precision you could see. Nobody had worked that out. What he did know was that you needed good glass. One of the reasons Galileo's telescopes were better than anyone else's is because he lived just outside of Venice. And to this day, Venice has some of the best glass workers in the world. So he would buy 100 discs of glass and pick the 10 that didn't have bubbles that seemed to be even all the way through, and then grind them down. And if you grind them down, you grind them into spherical shapes, which does not focus. But if you cut off most of the sphere and just look at the light going through the middle, it focuses nice and sharp. But you lose a lot of other things he didn't realize he was losing because they didn't understand how the instruments worked. other pictures of his telescope. But more than that, this is the first instance in human history where you're discovering something about nature that you can only see with an instrument, and an instrument that not everybody has. The philosophers of science tell us that all data are theory-laden, that instrumental effects affect what you're going to see. In other words, I'm looking through the telescope and I will see what I know to look for, which is a little bit better than saying I will see what I expect to see. At least if you see something you didn't expect to see, you had to have expected to see something to realize you didn't see it. And that means that cosmology, the questions you're asking, the questions Galileo is asking looking at the moon is the moon a perfect sphere? Because the previous philosophy said it would be. And he's seeing craters, and he's seeing flaws. Anybody here use a small telescope? Take it outside. You've had the experience of showing your neighbors, and okay, you look at the moon and they go, "Oh, that's cool. What else can you?" Well, I know that there's this nebula, Omega Centauri. It's not quite dark enough to see naked eye, but it's kind of over here. And I'll look, and no, that's not it, and that's not it, and that's not it. And everybody's going, yeah, yeah. And your audience is slowly drifting away, because if you've got people waiting to look through it, that means you can never find them. The same thing happened to Galileo with the moon. The most important thing you can get after you get the telescope is a good tripod. Anybody who's an amateur astronomer knows it. You'll spend as much money on the tripod as you will on the telescope. Galileo didn't have a good tripod. He had this telescope. He had brought it down to Florence to try to get a job, which he got. He's heading back to his old home. He's going through Bologna. All the people say, "Hey, we understand. We got this new book. You're seeing these things. Show us your telescope." He brings out the telescope. He doesn't have a tripod, so he's hanging it on a thread from a tree. And the field of view is like almost nothing. And he's desperately trying to find the moon that night. And people are waiting in line, and nobody can see what he sees. And nobody knows how to focus it. Most people have never looked through a telescope before, which is not trivial. Anybody here who's set up telescopes for the public, you know what that's like. And several people write scathing articles about what a fake and a fraud Galileo was. I couldn't see any of the things he's talking about. He's making it all up. That's what he's dealing with, because he's dealing with something that no one had ever seen before. And I don't just mean the moon, I mean the telescope. But worse than that, what constitutes winning? If you're an Aristotelian, you want to demonstrate things as if a mathematical theorem can be demonstrated. And that's what Galileo claimed. And Cardinal Bellarmine, who is, arguing with him, says, okay, if you can demonstrate that the earth is moving, then I'll go back and reinterpret scripture. Show me the demonstration. Galileo says, well, but what about this? And what about, you read Galileo's works, you find out most of his demonstrations don't work. Not only that, but in the last 10 years, there's a friend of mine in America taught community college, the lowest of the low. In Kentucky, the lowest of the low. I figured, why should I listen to this guy? Well, his students were very bright. They were not well educated. That's why they're going to community college. And he'll teach them something about astronomy, and they'll go, yeah, how do they know that? And he's going, that's a good question. I know how we know it today, but how did they know that back in 1650? Well, you can read Galileo to see what he's talking about, but Galileo makes some snide comments about his enemies. Nobody's read those books in 100 years. People arguing against Galileo for the next 50 years are all writing in Latin. It's been more than 100 years since anybody had bothered to read these books written in medieval Latin who knew medieval Latin and knew astronomy, because our education system bifurcates people. You do the classics, so you can do the Latin, or you do the astronomy, so you can do the maths. But you don't, heaven forbid, it would do either or both. I actually did classics in high school. Classics is really important because it teaches you how to think. Latin gives you logic. And Greek, ancient Greek, if you're going to be a scientist, it teaches you how to make those letters that are in the equations. Really important stuff. What we know today is that we think a theory works if there's a high probability that it will work. These are real data. These are data that I've taken in my lab. And you can see the pattern. But you can see that any given data point is going to be some distance from that pattern. And there's this one data point, there's one red dot way off from all the others. Is that telling me something profound, or is it telling me that the instrument, hiccuped at that moment? Because it could be either. We have now developed mathematical ways to calculate how confident am I that I'm actually seeing something, but the confidence is never 100%. And if I've got an explanation, it has to fit the empirical evidence. And if it is consistent with what I think has been going on all along, all the better. People who are, think they know philosophy of science, who are not actual philosophers of science, have probably read one book, Thomas Kuhn, and he talks about scientific revolutions. And if that's the only book you ever read, you'd think that science is all about coming up with scientific revolutions, so they'll name it after you. Well, number one, they're never going to name anything after Consolmagno. But number two, that's actually not what we're doing science for. And revolutions really aren't what you think they are. It's not that everything you knew was wrong, but everything you knew was right, but in a way different than you realized before. But that's not even what Galileo was doing. Probable merely meant that, this is probably true because that's what I read in the book. And if it turns out to be wrong, it's not that the book was wrong, it's that I misread the book. And if I could find it in a book, that's probably going to be true, even if I could come up with another explanation, because those people in the past knew better than I did. Laws of probability hadn't been invented yet. Statistics hadn't been invented yet. And before I get off this topic of Galileo, I want to remind you 3 things that they never tell you. Number 1, he was not an atheist in the future, from the future. He was a good Catholic. His 2 daughters were both nuns. Now, he never married their mom. He was an Italian Catholic, but still, Galileo was not convicted of being a heretic. He was not sent to jail. He was not executed. You can read the transcript of the trial. And at the end, when the trial was, what do you want me to change in the book? I'll change it. And the answer was, no, you can't change it. We have to find you guilty of something, which is really weird. And at the end, they say, well, here's the vote 7-3 heretic. And he goes, where's my heresy? And they go, 7-3, you are guilty of vehement suspicion of heresy. You are guilty of being suspected of being a heretic. Okay. The famous Galileo abjures. Galileo stands in front of the world and he says, I reject anything and everything in my writing that is contrary to the church's teaching, and never says what any of those things might be. Talk about being Jesuitical. Everything you know about Galileo is probably wrong, but the truth doesn't make the church look any better. Maybe they went after him for political reasons. Maybe they went after him because he made the Pope look foolish. Both of those things were going on. We just don't know. But it was not this, war between faith and science. You want to know more? Hilbrun talks about Galileo and talks about the whole history. All of these ideas that there was this conflict of worldviews, that he made political enemies, he made personal enemies. Of course he made personal enemies. He was an Italian. That's what we do. What is true is that the brilliance of Galileo was not his theories. Hilbrun can find the people who had come up with those theories who were his teachers. The brilliance of Galileo in many ways was the way he could assemble those ideas into a coherent picture and then write about them in language that anybody could read. So if you guys are studying science in the back, learn literature, learn how to write, learn art, learn how to see, because those are the things that made Galileo stand out from all the people around him. Maurice Finocchiaro has this collection of all the documents translated into English. You can read what Galileo said, you can read what his enemies said, you can read the transcript of the trial. I just will remind you what my friend, the guy who read Galileo and his enemies points out. Galileo didn't have the goods. Galileo had 2 proofs that the earth was turning. The tides show that the earth spins. That's why we have 1 tide a day. And somebody goes, actually, we have 2 tides a day. So the later edition, he crosses out, that's why we have one tide a day. But he still says the tides turn to give. No, it doesn't work. Galileo says, if the Earth is moving among the stars, and the bright stars, which must be closer to us, that's why they're brighter, will appear to move compared to the distant stars, which are dimmer, which is why they're farther away. And one of these days, in fact, Galileo saw the star, the middle star of the handle of the plow or the handle of the Big Dipper, which you can see in a telescope as a double star, a bright star and a faint star real next to it. If you had been down here, you could have seen that with Alpha Centauri. And as you look over the period of a year, the bright star does not move compared to the dim star, which you would say would disprove his theory. Instead, what he did was never publish the data. It would be 200 years before people realized what was wrong with Galileo's arguments, how the tides actually work, how stars really are not all the same brightness, and just because it's bright doesn't mean it's close. At the end of the day, is Galileo a villain or a hero? He hated people who stole ideas from him, but then he was stealing ideas from all over the place. Hilbrun says, where a new idea appears in Galileo's writings, you can find it in his teacher's notebooks. He hated authority. He said, don't trust authority. Where did he learn this? Because he was taught to distrust authority by the authorities in his life. His dad was basically a rock musician, an itinerant who sort of showed up often enough to father a bunch of children, but that was it. I remember when I was a kid, a fellow I knew had a badge in high school that said, question authority. And I go, question authority? Says who? He was furious when his friends were not faithful to him, but then he abandoned those friends when he got a better job in Florence. He abandoned his patrons who had gotten him to double, they got the government to double his salary, and then he walked away from it. He left his mistress and 3 kids behind. On the other hand, he was the only one who really understood what he was seeing. He understood that it was important to tell the world. All of the people who knew him and worked with him deeply loved him, including the children that he abandoned. And for all of the abuse that he got from the church, he never abandoned the church. He never fled to the Protestant North. He could have, he didn't. Galileo's a complicated guy. Don't try to put him in a box. But Galileo is a human being. Why are we surprised that he was a complicated guy? And it really wasn't until Newton's laws of physics that we came up with the idea that we could make Galileo work. And the science that was done by either noblemen or doctors or the reverend. By the 1890s, the Pope puts together a Vatican Observatory to show that religion is not, beholden to the myth of Galileo. The myth of Galileo was being invented in the end of the 19th century. That's where you find the first books that tell us the things that you all learned in school. Because nobody beforehand said that about Galileo. And popes through the 20th century identify astronomy as a place where you can, be inspired to prayer, a place where you can, encounter God. I just throw in Georges Lemaitre, who's also got a familiar collar, a few of us with collars like that. He was a Catholic priest with a degree from MIT, like I do, who came up with the idea that the universe was expanding, and people made fun of it by saying, oh, it was that Big Bang theory of his. He's doing that just to make, Genesis work. And he's going, no, it's where the data are. And besides, Genesis is not about creation. Genesis is about the creator. And what Genesis says is God made the universe. And what the Big Bang says is this is our best guess as of today as to what happened after creation got started. John Paul II, science purifies religion. The laws of nature make us want to contemplate the universe with gratitude. Through us, the universe becomes aware of itself and its maker. And this is the new thing that Pope Francis added. He's suddenly remembering that science is not a bunch of equations in a book. It's something done by human beings with human frailties and human desires and a human attraction to the truth, which is an attraction to God. When Francis wrote Laudato Si, he's talking about climate change and just a couple of things. Carl Sagan, who I was making fun of as being a media star, was one of the people who recognized climate change happening in other planets and saying maybe it'll happen here on Earth. This is a professor I had at that time. But the idea's been around for a long time. It was talked about in 1956 in the New York Times, referencing work by a fellow named Tyndall in the 1860s, who recognized that the atmosphere of Earth is heated by the absorption of infrared radiation due to carbon dioxide. He was also a vicious anti-Catholic, but, he's a complicated human being. And that's what Laudato Si is about. Fixing the world, fixing climate change is not just about climate change. It's a symptom of human sinfulness. And that's never going to go away. There's no tech fix that's going to fix things. But it's also concern with the created universe. He was a Jesuit. I'm a Jesuit, the Society of Jesus. Who was Jesus? Jesus was God saying this physical universe is so good and so wonderful. I'm going to be part of it. I'm going to send my son so he can enjoy chocolate too. And if not chocolate, at least a good fish dinner. What we need to do, besides developing new technology, is a new ethic. It can't just be save the whales. We are gods that can control nature. Nature is not a god that we have to be involved in. And certainly, any call to action which tells you what they ought to be doing over there misses the point. It's what do we have to do? We have to fight the human sinfulness of greed and the desire to be comfortable that we all live with. And there's so much to do that we can at least start with the easy stuff. But going back to JP2, he has a line in one of his encyclicals: faith and reason are the wings that lead us to the truth. Sounds very pious, sounds very pretty. Think about what's that saying. Faith and reasons are wings, equal wings. We need both. Here's a famous bridge. Notice that on one side they had to build a tower because you can only build a bridge from places of equal height. Faith and science can only be bridged if they're considered equals. By the light of God, we see our shadows. We're creatures of this universe, subject to the physical laws and God's laws. The scientist is a human being, full of human sins and human brilliance. Our problems are human problems of good and evil. T.S. Eliot, writing in the 1930s, looked at that Whig view that science and technology is going to solve all of our problems, looking at the fact that in Nazi Germany, they'd managed to come up with some really technologically sophisticated death camps. Maybe science and technology isn't all the answer. And he decides of people who are trying to come up with systems so perfect that no one needs to be good. Those systems don't exist. We need technology. Not only that, I love technology, but I also need and love to be trying to be a good person with that technology, knowing I'm going to screw up, knowing that I can't fix it myself. Let's go back to those fundamental shifts. That golden age mentality, technology isn't going to bring a new golden age. Faith and reason have to be equals. What are the roles of instruments and technology? It's an extension of the human. It's not a replacement for the human. Even if you call it artificial intelligence, it's still an extension of the human. It's not a replacement of the human. And even our reason lives within the matrix of the assumptions we've made ahead of time that sometimes we even don't know we're making. I end with this marvelous quote from Chesterton. The essence of pantheism was that nature was our mother, but the point of Christianity is nature's not our mother. Nature is our sister, not a solemn mother like the pagan worshippers or to the Wordsworth or Emerson. But nature is a sister and even a younger sister, a little dancing sister to be laughed at as well as loved. You don't exploit your sister. You're not afraid of your sister, except when I was 10 and my sister was a little bigger than me. You love your sister. And that is our relationship to this universe. Because why are we doing the science? not to get rich, not to get powerful, but out of love. Thank you very much.